Hi, good people. So, welcome to the second episode of my Opensearch series. In the first episode, I had covered how you can run a single node instance, Opensearch instance, using Docker on your local machine. And then we had used that instance, and I had showed you how you can connect to that instance over HTTPS using the Opensearch Java high-level REST client. So in this episode, I'll be giving you a brief overview about index and index template. So let's see what is an index. So an index is, you can think of an index in OpenSearch as what a table is in a relational database. And the documents that you put in the index is like the rows of the table in a relational database. So why would you want to use Elasticsearch over a relational database? One is Elasticsearch is very good at full text search. And second is you can do a lot of analytics on that data. Elasticsearch or OpenSearch is very good at it. So in this video, I'll be using Elasticsearch and OpenSearch interchangeably because OpenSearch is nothing but a forked out version of Elasticsearch version 7. So let's see some of the very common use cases is log monitoring. So when you run an application in a distributed environment, you have the logs being generated across all those machines of the distributed environment, and you need some way to aggregate those logs. So Elasticsearch is heavily used for that across the industry. So because it is very good with full text search, so you can query that log data, which is unstructured data, in a lot of in a lot of useful ways. So it's a very important use case, a very widespread use case. Then it is used for infrastructure monitoring of system metrics, a visualization of that. Then you have application performance monitoring metrics. Any kind of enterprise search use case can be used for it. And Elasticsearch also has a lot of function ability to work with geolocation or map data. So that is also a good use case. So yes, now that we've covered the use case, let's see how we can run it in a multi-node setup. So I'll be using Docker Compose. So I have a link. So I've put this link in the GitHub. So this is what I've used. I followed this link to get the setup done. So they're using Docker Compose. So I'll still be running it on a single machine. But in a typical production environment, this multi-node setup will not be on a single machine. It will be in a distributed environment running multiple machines. So these nodes will be actually running in actual across physical machines. So, but for our purpose, we'll be running it on a single machine using Docker Compose. So the Docker Compose file is given here. I have made some minor modifications. I have put it in my GitHub repo as well. And so once you have this Docker Compose file, all you need to do is run Docker Compose up. So I should already have this running. So here I have it running, and here you can see that I have 4 containers running here. These three nodes, OpenSearch node 1, node 2, and node 3. These are the data nodes. And then I have the OpenSearch dashboard running as well. This is mostly for visualization of the data that we could be indexing. So once we have this, so we'll be using, so if you see OpenSearch dashboard, it exposes the port 5601. So we can open it 5601, and it gives us a dev tool. So this dev tool we'll be using for running the commands on OpenSearch. So it's quite similar to a Postman console. Okay. So let's see how we can create an index. So at this point, so this cat indices is used to list the indices that are there. So currently these are some default indexes that OpenSearch comes with. So these are not user defined ones. So we'll create an index right now. So we'll see how we can do it. So I have downloaded a movies database from the internet, and I will be indexing that data here. So let's see what is this data form. So here you can see that this is a sample document. So Elasticsearch works with JSON. So Here you can see these are the attributes that are there. Adult, is it an adult movie or not? Then the budget of the movie, the genres, the ID, the IMDb ID, the language, title, some overview. This is some free format text, popularity, poster path. This can be the path to the poster in S3 or some other object store. Then you have the production companies, production countries, release date, revenue, runtime, language, status, if the movie was released or not. You have a tagline, title, is it a video or not, the average vote, and the number of votes that this movie has received. So this is sample document. So it also has a movie collection. So is this movie a part of a collection? So this is the Toy Story collection. So Toy Story has a number of movies, Toy Story 1, Toy Story 2. So this movie is a part of the Toy Story collection. So as you can see, it supports nested structures. So let's take one and we'll index it. Let's take one document and let's index it. Okay, so let's index this document. So this is the path. So this is the index that I want to create. So once I put this data, Elasticsearch will auto create this index for me. And this is the path that you need to provide. So underscore doc or underscore create, both will work. So underscore doc will, if there's an existing index by this ID, existing document by this ID, it will update that document. Underscore create is explicitly for insert. So if there's an existing document, this will fail. So let's try this. So it says that it has successfully indexed one document. So let us see what. So let us query. So this is the query that will fetch all the data in that index. So here you can see that it has got one hit because there's only one this thing. So before we go there, let me just show you that the index is created. So let me do an in. So here you can see that the listing of the indices give me the TCV1 movies metadata. So Elasticsearch has auto-created this index once we tried to put some data inside that index. So let's see how Elasticsearch has created this index. So whenever you put this data, based on the data, it infers the schema for the index. So if we try to have a look at the schema, we'll see. So here the mapping is the schema of the index. So here you can see that it has mapped adult to type Boolean, budget to type long. For genres, it has put the type as text, but it is also indexing it as a keyword as well. So genres is text, but genres.keyword you can use to use it as a keyword. So this is of type keyword. So you can index the same field in multiple ways. So the field genre is indexed as text, but it will internally create another field, genres.keyword, which it will index as a keyword. Then you have ID, which is again any string field that it gets. By default, it will index it as a text, and it will also create an internal keyword field, which it will index as a keyword. So all of these, it will do the same. Then popularity as float, poster path companies. So all of these. So anything which is any attribute that you have. So let's say we have the production companies. So it can always, so it says it will be indexed as a text. So this does not mean that this is a singular thing. So you can have multiple values here. So any attribute can contain a list of values. So if you see the production companies that we had here, production countries or the production companies, this is a list of values. So you index it as a string, but it can be a list of strings. So that is true of any attribute. So any attribute, if I say budget is long, it can be a list of long. Similarly, genre is a string, so it can take a list of strings. So any attribute can take a list of values. Okay. So typically for any example use case or any trial and error experimentation, you can use these auto-generated indexes. But typically in a production application, you won't want Elasticsearch to infer the data types for you, but rather you as the developer would want to explicitly say that this is my attribute and this is the data type I want for it. Because if you think of it, these something like a poster path. I don't want to index the poster path because I'm never going to run a query or any aggregation on the poster path. So it would be unnecessary to index that data. So I just want to keep it. I don't want to analyze that data. So I would, and not only is it analyzing that, so it is putting it both as a text. By default, it will be putting the poster path both as a text as well as a keyword. But I would not, that would be unnecessary overhead for me. And that only the application developer can decide that what is the use case of that attribute, and based on that he can decide the mapping. So typically in a real application you don't want to infer the schema, but in a lot of trial and error or experimentation use cases you can use that. So let's also see one thing. So here if you see, the movie collection attribute is not there because the document that I had put here did not have the movie collection. So let me put another document which has the movie collection. So what we'll see is Elasticsearch will automatically update the schema to add the movie collection attribute to it. So we'll take this. So in that way, Elasticsearch is flexible. But if you want to, so this, and what is the ID? 862. That's what I would put. 862. So let's see. Let's index this. So this is also indexed. Now if I try to get the mapping, okay, let's see what happened. So TCV1 movies index metadata is there. So why did we not get the mapping? Okay, mapping is there. Not sure what happened. So here, if you see, Elasticsearch would have added the yeah. So the movies collection attribute has been added, and this is a nested object. So it has its own set of properties. So it has a backdrop path, it has an ID, it has a name, and it has a poster path. So if you think of it again, the backdrop path has been indexed as a text and a keyword. The poster path has been indexed as a text and a keyword. But these are essentially, let's say, path to S3, uh, where we have these images stored. So we are never going to search on it or do any aggregation on it. So this indexing is an unnecessary overhead. So if we do our own schema, if we define our own schema, then we can handle all these. So while Elasticsearch is flexible with this, so what we cannot do is change the type of an attribute. So once we have budget as a long, now if I try to put budget as a string, so it should throw an error. So it says that the type budget is of type long, whereas you're providing incompatible type string. So the indexing will. Yeah, so till now we have seen that how we can index a document in Opensearch, and when we index the document, how Elasticsearch or Opensearch auto creates the index for us. So next what we'll do is we'll explicitly create the index. So let me first delete this index, then we'll explicitly create this index. So we have deleted. Just quickly, let's verify that the index has been deleted. So yeah, we don't see the TC V1 movies metadata. So index is deleted. Now let's quickly create the ask Elasticsearch to explicitly create the index. To do that, let me just show you the data that will be used to create the index. So let me show you from here. So this is the call data. So create index request. This is the data we'll be using to create the index. So what does it take? It takes something called an alias. So you can have the name of the index as tc underscore v1 underscore movies metadata. But when you add an alias to it, you can use the alias to refer to that index as well whenever you are querying the index. Then we have the setting. So I'll come to the setting later. And then we have the mapping. This mapping we've already seen that when we were indexing the document, Elasticsearch was using the document to infer the mapping. So in this case, we are explicitly providing the mapping. So here you can see that what I've done is that for all those path attributes that we had, which were essentially pointing to some file in S3 or something, which we will never use to do any query or any aggregation. So for all of this, we are putting index as false, which means that it will not analyze that. Opensearch will not be analyzing that attribute. It will just save that as is. And you won't, and if you try to query or do an aggregation by that attribute, it will fail because Elasticsearch will say, I have not analyzed this attribute, so you can't do any query or aggregation using it. So if you see backdrop path, poster path, so all of this, I have put index as false, which means that Elasticsearch will not be doing any analysis of that attribute. Also, one thing I forgot to mention the other time, so we had I think there was some release date. Let's see. There was a date attribute. If you see release date. So this date, if you see in the document, it is difficult to make out if this is a date or this is. So here, if you see release date is year, month, day. So we are passing it as a string. But Elasticsearch, even if we look at the inference that Elasticsearch did and the default type that it had set for release date, it was date. So Elasticsearch is smart enough to know that that is a date and that is the type it had put as well. So inferred as well. So here also we'll, but here we are not relying on Elasticsearch to do that inference. We are putting the type as date by ourselves. So here we have all these attributes. So everything is set. And in addition to the mapping, we have the settings. So what does the setting say? It says what is the number of shards, number of replicas, and the refresh interval. And then we have the alias. So I'll come back to the settings later, what this means. So meanwhile, let us just create the index explicitly. So let's copy this command. So here, one small change. So the data path data slash create. So I'm just referring to the file. I'm just passing using the curl command to do the put request, and the path that we have to use to make the put request is the server, and then this is just the index name. So this will create this index using this data that we are passing it input, and we are saying the content type that we are passing is application JSON. Okay, let's send it. So yeah, the index has been created. So let's take a look at the index. So the mapping, see. So here you can see the mapping is whatever we had provided the mapping, it will use the same. It will use the same mapping. Let's look at the setting and see what the setting means. Try to make what the setting means. So the most important thing is the number of shards and the number of replicas. So number of shards is 2, number of replicas is 1. What does this mean? An index is further subdivided into shards. So when we put documents in this index, so suppose we have we have put 100 documents in this movies index. So on an average, because we have created the index with 2 shards, so 50 documents will be put in shard 1 and 50 documents will be put in shard 2. This routing is determined by using the hash function on the ID of the document that we are putting. So on an average, we'll have 50 documents in shard 1 and 50 documents in shard 2. So in this case, because we have only 2 shards and we are running a 3-node cluster at this point, so there's no further scope for scaling this index. But let's say we created the index with, let's say, 18 shards. So let's see an example. So here I have a 3-node cluster running, and we have created an index with 18 shards. So now, as the data grows in that index, the shards will also grow fatter, and at some point, our queries will become slower. So what we can do to improve the queries, the query performance of the queries, is we can scale up the cluster. So let's say I add 3 more nodes to the cluster. So what will happen is that I have added 3 more nodes. So the shards will again be redistributed. So let's say the shard 1, shard 2, shard 3 is here, and shard 10, shard 11, and shard 12 is put in node 4. Similarly, you can have 4, 5, and 6 in node 2, and 13, 14, and 15 can be put on node 5. Similarly, for node 3, 7, 8, shard 7, 8, and 9 can remain on node 3, while the remaining 3 will be moved to node 6. So in this way, we have brought down the load on each node. So as the data grows, we can add more nodes, and the shards will be again redistributed, reducing the load on each node. So as the data becomes less again, so if for some reason, let's say we delete this index and we create a new index with some new data, and the data in that index is lesser, so we can again bring down the cluster size because we don't need so many nodes in the cluster. So that is how we can scale up and scale down an Opensearch cluster. So let us see, in our case, we have created the index with 2 shards. So how are the shards distributed? Let's do the listing of the shards. So we see that these are the shards that are there for our index. We'll just copy it here. So here we see that the shard 0. So we had asked to Elasticsearch to create the index with 2 shards and 1 replica. So here, what that means is that there'll be 2 shards, and for each shard, there'll be 1 replica. So 2 into 2 is 4. So that is why we see that there are 4 shards. So shard 0, there's 1 primary and 1 replica. Same shard 1, 1 primary, 1 replica. And shard 0 primary is in node 3. Shard 0 replica is in node 1. Shard 2, shard 1 primary is in node 2, and shard 1 replica is in node 1. So let's see. So Elasticsearch is also fault tolerant. How it accomplishes that is using this replica. So even if we lose a node, we should not lose any data. So right now, uh, right now, let's see that the data should still, we have how many? We have 9 documents here. So what I'll do is I'll bring down 1 node. So let me bring down Opensearch node 3. So this has the primary of the shard 0. So okay, we have brought down Opensearch node 3. And let us see if we have lost any data or not. So yeah, we have got the response, and we still have the 9 documents. So we haven't lost any data. So let's quickly see that, yeah. So here, if I do the Docker container ls, this container is Opensearch node 3 is in pause state, and we still haven't lost any data. let me do a listing of the shards and see how the shards are distributed right now. So copy this. So this was our initial distribution. Now what do we have? So primary 0 has been moved to node 1, which was in node 3. And replica of 0 is currently unassigned. So there is no replica currently of 0, node 0. And node 1, sorry, not node 0. There's no replica of shard 0. And shard 1 primary is in node 2, and the replica is in node 1. So everything is distributed inside node 1 and node 2. So node 3 actually had the primary of shard 0, which has now been moved to node 1. And node 1 had the replica of shard 0. So this replica has been made the primary right now, but the replica for 0 is currently not assigned to anyone. So let's see if that has changed or not, or Opensearch might just wait for some time for that node to come up. Okay, so it might have some wait time, but now if you see, it has again copied over the data. So here the primary of 0 is node 1, which was the case here, but the replica of 0, shard 0, was unassigned, but the replica of shard 0 has been now is on node 2. So the data has been copied from node 1 to node 2, and that copy has been made the replica. So that is how a fault tolerance is achieved on Opensearch. So even if you lose a node, the data is not lost. Opensearch will use the replica to get the data on some other node. So now I'll just show some easy ways, some sample queries to query the data. So Opensearch actually provides a very powerful DSL to query and do aggregations on the data. So I'll just give you some example here. I'll not go deep into the Opensearch DSL, Query DSL, because it requires a very long video of its own. So first, let's see how we can list all the data that we have. So this is how you do the listing. So the query match all. So let me do that. So here you'll get all the data. So if the data spans in huge number, you need to do some pagination. For pagination, we can use the size attribute. So if I just want to get the first 5 documents, I'll use this size. So here you can see that the total hits is 9, but the number of hits the query would have returned me, the search request would have returned me is 5 only. So we have got 5 documents back. So if I want to get the next 5 documents, I can give an from. So the from will start from 5 and go till 10. So this should give me the next 5 documents. So here you can again see that I should have got the remaining documents. We had 9 documents that we had indexed. So the remaining 4 have come here. We can also sort. So we can sort using any field or a combination of fields. So here, let's say we sort by the release date. So that also works. So in this way, you can achieve pagination. Next, what we'll do is in this index, we only have only 9 documents. So we'll use the Java code to index a few more documents. So we'll use this index. So we'll create another index and we'll use this we'll index a few more documents in this index. So let me first go to the file that we have. So this is the movies metadata CSV file, which I have downloaded from the internet. So this has around, I think, 45,000 records. Yeah, it has 45,000 records. So that will take quite some time to do the indexing. So instead, I'll create 500. I'll create a file with 500 entries, and that is what I will use to do the indexing. So here we have 500 records, 500 lines. So we'll index these 500 documents. The first line is the header. So I'll quickly go through the Java code as well to show you how we do it. So we'll again use the high-level REST client. So in the main method, we'll first get the high-level REST client, and then we have a movies data parser method. So we'll use this to parse. So first it will do the setup. So setup will be creating the index. So this is the index. So this is the index object we have created, and then we have an index manager class where we have a create index method. So we'll be using this create index method to, so here you'll see that we again put the settings and the mappings. We create the mappings, the settings, the mapping I have put in a file here. So here I have the mapping. So I'll put the mapping, the setting, the alias if it is defined, and then we'll do the create index. So that way we should have the index created. So once the index is created, I create the parser object. I'll ask the parser to parse the data and index it in batches. So the batch size I've mentioned is 50. And this is the method which does the indexing. So it will parse the data from the CSV file, create batches of 50, and this list of 50 movies it will pass. And here we'll use the bulk indexing API to index the documents in in Opensearch. So let me run this and see if that works. So we'll use Gradle run. So the run is complete, successful. So we should have 500 records in the or documents in this index. Let's see. So here you can see that we have 500 documents, 499 documents in this index. So next, let's see that how we can. So this is a query. The match all query is used to give me all the records in the index. So we can have a lot of other ways in which we can query the data. So let us check that. So the first way you can get the data is if you know the ID of the document that you want to get. So in this case, let's say this is the ID of the document that we want to fetch. So we can just give it underscore doc, index underscore doc, then the ID, and we do a get. This should give me the document that we are looking for. So based on this ID, Opensearch will apply the hash function. Based on the hash function, it knows which shard contains the document. It will go to that shard, fetch the data, and give it back to us. So that is how it works. Let's see how we can do a search based on an attribute. So let's do it. We don't need any pagination for this. And we don't need to do any sorting. I'll remove all of this. So instead of the match all, we can use something called term. So the term query is useful when we are trying to do a match on a keyword attribute. So any attribute that is indexed as a keyword can be used for in a term query. So let's see our genre. So genre we have indexed as a keyword. So if I look at the mapping, you can see that the genre should be a keyword. So the genre type is keyword. So we should be able to do a keyword, a term query on the field genre. And what do we want? Let's say we want to see all the action movies that are there. We want to list all the action movies. So here you can see that the genre is action. One of the genres is action, so it will give us that. Then we have science fiction. So we can do on any of these fields. And let's see, let's do something. let's say that you want to do if the spoken language is HU. I don't know what that is, maybe Hungary, but I mean, I don't know what that language is. But let's say for spoken language as Hungarian. So let's do that. So what is the spoken language here? So you can see HU is one of the spoken language in this movie. Okay. So next, let's say that Paramount Pictures is the production company. So in this case, let's say know we don't know so the term query has to be an exact match. So if I give genres and then the value as action, this will not give us any hits because it term query. So the keyword type only does exact matches. So if we do a term query on a keyword argument, it has to be an exact match. So otherwise, it will not work. But you can do full text search with Opensearch. So what we'll do is let's take New Line Cinema and or let's say Paramount Pictures. So if the production company, let's say we'll search by Paramount. So if the production company is Paramount, let us do the search. And in this case, because there's a text field, we'll use a match query. So let's give it a match. And instead of this, let's no need for this. So we'll just give it production as Paramount. So here, if you see, production companies is Paramount Pictures. Because this is a text field, so Elasticsearch will be analyzing it. So it will see that it is composed of two words, Paramount and Pictures. And even this Paramount, you can give it in a small case or a capital case, both of which will work. So both of this will work because Elasticsearch will be analyzing the text field, unlike the keyword where it is only an exact match. Okay, so then we can also do something like a vote count. So wherever the vote count, we only want to list where the vote count is greater than, let's say, 100 votes. So in that case, we need to use a range query. So we'll use a range query to say that on vote count, and we'll say it has to be greater than 100. So let's run this. So here you'll see that we have quite a few hits, 207 hits. And what is the vote count for this? So vote count is 2413. So the vote count is greater than 100. Next, let's see that we want to see all the action movies which has a vote count of greater than 100. So in that case, we need to do a Boolean query. Whenever you're combining multiple conditions, so you have and or clause, so you want to combine multiple conditions, then we need a Boolean query. So we'll see how to do a Boolean query. So we'll say bool and then yeah. So for this, for combining, we'll use the Boolean query. So here you can give must. So must is like an and clause. So here we'll see that we'll have a term query. So we'll combine multiple conditions. So the term query is on, let's say, genre. And this is the value is, let's say, action. So all the action movies delete this actually. You can just use and we want a range query. So we'll have range and on which field? On the vote count, which is greater than 100. So here you can see that we have a list of all the action movies where the vote count is greater than 100. So you see genre is action and the vote count should be greater than 100. The vote count is 459. So this is how you combine multiple queries. So the must clause is used for, it is like the and. So let's say we have another query where we want to get the list of all the action or comedy movies. So in that case, we'll use the should. Instead of must, we'll use should. So here we'll put comedy. So this will give us the list of all the movies which belong to either action or comedy. So this one is both an action comedy. So let's see another one. So this one is again has both action and comedy. This is action and comedy. This also has action and comedy. Action and comedy. Okay, all of these have both action and comedy, but any one of them, if it matches, it should select that. So it does not necessarily have to be only action or comedy. So let's do a pagination. Let's give from, let's say, so this has 269 hits, right? So let's say starting from 200, and we'll get the next 50. So let's get that. So here you see, this is only comedy. So there's no action. So any one of them matches, it should give us a hit. Okay. Opensearch DSL is extremely powerful and there's a lot that we can cover, but it would require a video of its own. If you would like me to make a video on that topic, then let me know in the comment section and I'll try to do that. I would have liked to cover index templates also in this one, but this video would become very long if I do that. So I'll cover it in the next one. If you learned something new in this video, then please hit the like button and share this video with your friends. Thank you.